So it's time we do 56K. This is a Lucent PortMaster 3. So these are identical to Livingston PortMaster 3s. Lucent bought Livingston in '97, I believe. But this is a remote access server. Essentially, this is almost like a dial-up ISP in a box. And this thing actually is able to support 56K, which you can't do with something like a standard US robotics modem. So I bought this one maybe a year or two ago from the VCF flea market. I got a great deal on it. It does have some issues, we're going to get into that. But first, let's flip it around and take a look at the back. So let's take a look at the back here and just go from left to right. So on the left here we have our power switch and then our IEC C13 connector for power. We have the fan over here. And then at the top here we have all of these slots for modem boards. So you can see that these are all stickered for 56 flex. That might be a little hard to make out down there, but these will support 56 flex. I don't know if they actually made anything higher than that. That would be interesting to learn, but this is what I got. So what's interesting about these cards is that some of these have 10 digital modems on them and some of them have 8. So with this combination, I actually am able to get 48 modems. So if you know anything about T1, each T1 will give you, I believe it is 24 channels, but then one is reserved for overhead or signaling. So that gives you 23 to work with. So you might notice down here that we have line 0, line 1. That means that we can accommodate 48, but then 46 of them are usable for modems. So this is essentially maxed out. So we just need 2 T1s down there and then we can use this thing fully. Now you might be asking, if this is maxed out, why is there this empty slot over here? And it's not just for symmetry here, but this unit will also work in Europe. So in Europe they don't have T1, they have E1. E1 is similar in that it has 32 channels, but 2 of them are used for signaling, meaning that with 2 E1s you could have 60 modems in this thing. So even if you had 10 modem cards, you would need 6 of them total. But in the US, we don't need this at all. So I was very lucky to get this thing fully loaded for America. Pretty good. So as I mentioned, down here also slotted is this motherboard. So we have our 2 T1 lines, or just 2 carrier lines down here using an AP8C connector, pretty standard. C0 are diagnostic ports, so this is serial. Then here we have some dip switches, which control something important, I'm sure. And then that's flanked on the left and right by these LEDs. So I'm sure this is for diagnostic connection, and this is probably for what we have on the right side here, which is every flavor of Ethernet. You got your BNC jack, you got your AUI port, you got your RJ45 port. So if you have an Ethernet network, this thing can connect it up. So this is an overview of what's on the back here, but let's actually go in, take a look inside. So now that we have the cover off here, you can see there's this shield on the one side that all of our cards are hiding under, and then on the right side here, we have our power supply. So the 120 volts AC mains comes in to this power supply, which puts out 5 volts DC. Funny enough, this fan here runs at 12 volts DC, and there's a little converter board over here that actually up-converts the 5 volts to 12 volts just for this fan. Pretty interesting. So I had mentioned that I got a good deal on this unit, and you can see by the fact that I've removed this connector between the power supply and the board that I've been in here before. And what I have found is that this power supply is broken. So you can see here, based on the cable here, we have our reds for our positive 5 volts and our black for your negative or ground. And that corresponds to these pins here. Now, if we touch some of the pins, so this one is supposed to be black, and then we touch one that's supposed to be red, we get a little chirp from my multimeter in continuity mode. So the positive pins are shorted to the ground pins. So this is not going to end up powering anything. Luckily, there is a mean well power supply that puts out 5 volts at the proper amperage, and I can essentially hack up this little cable right here and get it connected to that mean well supply, and then we should be in business. Now for actually securing it in here, I also did buy a piece of aluminum so I can use that as a backing board and then secure this all down so it doesn't go anywhere. But first, now that this power supply is confirmed to be bad, we know it's gone out, why don't we pull all of the cards out of the back here and make sure that none of the tantalum capacitors on them have shorted as well. It'd be really bad if we replace the power supply and then we power it up and then all of a sudden a bunch of capacitors blow up on this side. So let's go take a look at that now. So before I'm actually going to test these capacitors with the multimeter, I just wanted to show you the difference here between the modem boards. So you can see that they have these nice rows of these Lucent branded chips. And this is one of the 8 modem boards, this is one of the 10 modem boards. So here, these yellow components you see here, those are our tantalum capacitors that we're going to need to check. Now just to flip these over, take a look at the back here. You can see again here, we have unpopulated DIP packages here on the 8 modem board and populated ones here on the 10 modem board, as well as a couple supporting components it looks like on the sides here. So these also look like capacitors. They have a C labeling on them. I don't think they're tantalums, maybe they're ceramic or something, but I don't think I've ever seen a capacitor in that form factor. If you know what that is, let me know. Okay, so we have one of the modem boards under the microscope here, and I took out my Fluke multimeter, not really for any real reason, mostly just because I like it better, and the probes actually seem more sensitive than the Klein, so it makes things a little bit easier. Now, we don't actually need to see the display here. This is just in continuity mode, so when we have continuity between something, whether it's the probes themselves or just a piece of metal that goes straight through between them, you'll get a beep. So really we just got to keep our ears open at this point. So if we go under the microscope here, we have these 2 tantalum capacitors. So if I just hit the lead on one side and then the lead on the other, nothing. And nothing there either. So that's good. That means it's not shorted. Now if we zoom over here, actually if I position that maybe a little bit better, we have another 2, so we can do the same thing here. And just to show they do still work. So nothing here is shorted. We're going to do the same set of steps for all the other boards. I'll do that off camera. But if you've never checked for shorted capacitors before, it's that easy. Now it looks like the screws that affix the power supply to the chassis are these number 8 machine screws. So if we're going to drill a hole, we need to drill it slightly bigger, but not as big as the head. So the closest bit that I have here is actually this 11/64 bit. So that's slightly bigger, but should not cause an issue with being bigger than the head, so shouldn't be too big. So I'm going to need to drill into each of these dots I outlined here. I'm going to take this punch and try to make a starter indentation. So this is a 3/8 prick punch, but I'm just need a tiny bit there, and then I'll drill into it. So it's crazy I don't have like a piece of scrap wood around here or something that I can just drill straight into, so I don't have to take this flimsy piece off the table. But let me go check that for a second. Much better. Okay, so screw holes are drilled. Screw fits in pretty well right there. So now that I have these done, let me take the new power supply and place it on top here to try to get it all sort of lined up to not conflict with the existing holes, then mark new holes. So for the power supply holes here, the larger screw that is actually for the plate, that'll fit there, but I'm going to use something smaller so I get a little bit more clearance between the screw holes. So I have this big nuts bolts assortment kit here, and an M3 screw, that should work perfectly. It'll still stay within the screw hole without passing through, and it's a little bit smaller. So I'm going to use just a 1/8 inch drill bit and drill those holes. I haven't really addressed it, but I have been using this file on the metal a couple times while preparing everything. So this is just a bastard cut file. It's not anything finer for finishing. This is mostly for material removal, and this is by no means like my good file at all. I bought this for something years ago, and it's been rusting out in the toolbox for a while. But really, I just want to try to get the sharp edges down, deburred. Same thing with the screw holes I'm making here. I don't want anything snagging on any cables over time or rubbing, and I also just don't want to cut my fingers while I'm putting all this in here. So I'm not trying to make everything exact. You can see it's still kind of rough, but it's smooth to the touch at least. So that's the idea behind this. Probably not necessary if you're trying to do this yourself at home, but makes everything much, much cleaner and less likely to cause problems in the future. So I figured this is a good time as any to actually talk about the replacement power supply here. So you can see I've already fastened it to the aluminum piece here. So my idea is, since it's going to be sitting like this, the wires are going to come in this way, go back out this way. So for my cut edges, I put those on the sides that are not going to be crossing paths with those wires at all. For actually mounting it on here, so I'm using the screws and nuts here, if I get closer here. So my idea is, if I ever want to remove this while it's installed without taking the whole aluminum part off, I have the screw, and then I have a nut, and then the power supply, and then another nut in here, so I could just unfasten the top one and then slide the whole thing off. Same over here on the other corner. Same configuration right there. So these are 10 millimeter length, and they are, what did I say before? Yes, the M3. So M3 10 millimeters, they're going to go right in there. So the old power supply over here, that's, you can kind of see it hiding out back here. That's an Aztec supply that does 5 volts at 22 amps. This one, this is a Meanwell LRS 150F-5. This also does 5 volts at 22 amp for output. So big thanks to Tekuru, who used one of these in his PortMaster, recommended it. Same for the Osmocom team, who had a PortMaster 3 with a dead PSU, used one of these. This is the sort of tried and true power supply replacement that everybody's doing here. So if we look back at the terminals across the bag here, we can see that we have our live, neutral, and ground coming in. So this will be the 120 volt feed. I believe that from what I've seen, people are wiring up the live and neutral, but not the ground. The ground is actually bonded to the chassis, which you can see off to the side here. I'm pretty sure that this whole case and through the screws and everything, it'll be bonded to ground, so we don't have to connect that up. Then we'll have our negative voltage DC and our positive voltage DC, so we have 2 terminals for each, which is pretty nice. So here I just put on a little ring connector here. You could do spade connector, but ring connector keeps it more secure. So these red connectors here, so these are crimp style connectors. Got a whole bag of them here. So number 6 seems to be a good size for these terminals, and it looks like that's pretty universal. I'm going to eat my words, pretty universal on a lot of the Meanwell supplies that I've seen. These seem to fit some other stuff here. So these red terminals, these are for a higher wire gauge. So from what I saw with this connector here, it's actually written on here, these seem to be 18 gauge wire. And I think that these are something like, hey, future me here. Sorry for the jump cut, but I'm about to say some really incorrect stuff about the sizing for these terminal types. So just keep in mind, these red ones are for 22 to 16 gauge, and these blue ones are for 16 to 14 gauge. So I incorrectly said that I would be using these blue ones, but actually I'm going to use these red ones for all the wires in this power supply because they all seem to be 18 gauge. So the way that I'm thinking about this is I'll do sort of a little bit of a fit test with this in the chassis and figure out a good spot to cut all of these wires. Probably try to cut it not quite at the end here because I want to sort of preserve that connector in case I want to splice it all back together in the future, which I probably won't do, but good to have that option. And then for each of these wires, they will get their own crimped terminal connector here. So in theory, you could double these up and do 2 per crimp connector. If you do the math on it, if you have 2 18 gauge wires together, every time you double a diameter, it'll reduce the gauge by about 3. So 2 18s would be about 15 gauge, which isn't really a gauge you would see in the wild, but that's well within our 14 to 18 gauge rating that these would work in. But doing 2 wires together like that, it doesn't produce the nicest crimp or the nicest connection. It becomes a lot less reliable than doing everything individually. So we'll just do each one with one of these connectors, and then we'll end up, because there's 8 conductors, we'll be doubling up on each of these terminals. So I'll do that fitment test here to see where we can do a cut through this, and then walk you through the process of crimping one. So I went ahead and I cut our connector here. I pre-stripped one of these wires. I did so to about 9mm. So if you have wire strippers like this, it makes it really easy. You can just put it in the jaws here, line it up to about 9, pull the trigger, good to go. So twist that a little bit, but I want to show you how we're going to crimp one of the connectors here. So you can see I have one of the red ring connectors, have the ratcheting crimper tool, makes it pretty easy. There's a red indicator here that we're going to use. So we will line up the connector here. Okay, it's easier said than done trying to get this where I can actually do it and the camera picks it up. But we have our connector here in the crimper. I'm going to make an attempt here to feed the wire in, and you will kind of feel a little bit of resistance for where the insulation of the wire hits the metal part on the inside of the crimp. So if we get that lined up again, right there, everything's together, and then crimp, and then this is a ratcheting connector, so if I give it enough, it'll just come right back open again. And then there's our crimped connector. Tug on it, it's not going anywhere. There's a little bit of our wire sticking out right there. What some people will do is actually solder that down to give it an extra strong connection. I don't think that's needed in this case. This crimp seems pretty sufficient. So I'm going to go ahead and strip the rest of these ends, crimp connectors on, and next time you see this, I'll have everything put back into the chassis and we can take a look at how it came together. So I have the new power supply mounted here in the chassis. You can see here how I have all the ring terminals wired up, same way that it was with the old power supply going back to this connector, as well as the main lines wired up right here. So the first thing that we're going to want to verify here, let's get the multimeter going here. So we have it in continuity mode. So we just want to make sure everything's grounded. So back here you can see there's a grounding point. And if I just hit ground, we have continuity. The whole chassis is grounded. So step number 1, good. Now we'll flip this over here into voltage mode, voltage DC. And if we turn everything on here, so this is plugged into power, so if I turn the outlet on and then turn the chassis on, you can see we have a green light there. So we just want to make sure that we're getting 5 volts, and if not, there's a screw here to tweak it. So we don't want to send too much voltage, we don't want to send too little. So if I put one probe on negative, one probe on positive, and get my hand out of the way, we're at 5.09 volts, which is good. When it's under load, it will dip a little bit. So 5.09, probably good to at least try to boot this thing up with. So let me quickly turn that off. So I did also 3D print this little shroud over here that I can put over the terminals. So I'll make sure to install that. That just keeps things a little bit safer. So when we plug this all in and actually wire this connector up here, we're going to want to make sure it works past just seeing the power supply light up. So we might see the fan slightly off camera here light up. There's some LEDs on the back we might see light up. But I really want to monitor serial output from the serial port back there. So I have a beautiful, it was new, serial cable here that I got for free at the VCF swap meet. We're going to need some adapters because there's a DB25 on the back of here, so we're going to convert that down to DE9, and then you need a null modem adapter. And then I'm going to be hooking it up to a more modern computer, so trusty USB serial adapter here. So I'm going to get all this chained up open a screen session on probably my Mac over here, and then turn it on and we'll see if anything comes up. Okay, so everything here is buttoned up. I have a screen session opened with all of my adapters and everything connected here. So the connector is connecting the power supply to the main board here. Now I'm going to turn everything on. Hopefully we don't hear any pops, and if we're lucky, we'll see something up there on the console screen. Alright, hopefully you can hear me over the sound of this terrible fan, but one of my adapters, the DE9 to DB25, was already a null modem, so I did not need this one, and I wasn't getting anything on the screen here. But if I take you a little mobile for a second here, excuse the shaky cam, everything is connected, we have a terrible fan bearing, and then if we look up here, PortMaster console login. So we are in. Okay, so we know that it works. At least it works enough to give us a console. So power supply's in, but I'm sure you noticed that the fan back here was more than a bit noisy. So we're gonna do the right thing, and we're gonna put a Noctua in it. So this is the NFA8. This is an 80mm 12-volt fan. And it should be, I mean, as far as flow rate, this stock fan, this does 29 cubic feet per minute. This Noctua does 29.6 cubic feet per minute. Something like that, so it's very close. I had seen that the Osmocom folks, they did this with one of the included low noise adapters. So that takes it down to about 25 CFM. I'm very much for one, while I'll update a bunch of parts and everything, I want to try to keep it as close to stock performance. So I know that that CFM is probably meant for if you have this thing like in a rack somewhere and there's going to be a lot of heat generated. But I still would like to keep it at least stock in terms of how much cooling that we're going to get out of it. So we can always add the LNA at a later date, but right now I'm just going to plug it in without it. Now the only complication to this all is that this existing fan, it just has a 2 wires here. So we have our black and our red, but these Noctua fans, they use 3 wires. So I have this little, it's a 3-wire to 2-wire adapter. And generally what I'm just going to do is use this socket end here so you can see it's populated for 4 pins, but only 2 pins are actually in the connector. And then the other end is just a 2-pin connector, but what I'm going to do is cut this in half and then splice it in there. That way, the fan is going to be swappable without me having to do any rewiring in the future if I need to. So let's get this fan out of here, snip off the wiring, splice this in, and then give everything a nice little test. Okay, so you saw that the fan works properly. That's pretty good. Uh, at idle, you also saw that I took a reading that we're at about 60 watts of power usage here. So I think that where I am, that's, if I'm running this continuously, that's like $8 to $10 a month, which is not great, not terrible. I would definitely love if somebody has the stock power supply working, and I guess also the stock fan. Just let me know what the power usage of yours is at idle. I'm curious if this Meanwell is much more efficient. So now that we know everything works here, I'm actually going to do like a step backwards, because going through here and taking out that old fan, this thing is pretty filthy. So I'm going to actually take out the power supply and some of this wiring as much as I can in here, take this whole thing outside and blow it out with air, and then try to clean it up a little bit if possible, maybe get some rags or something, because there's a lot of gunk here. But yeah, let's go ahead and do that now. Okay, everything is blown out, and I wiped down the surfaces as best I could with alcohol, as you saw. That did a pretty good job, but afterwards, I ultimately took this top part here over to my sink, and I didn't film anything because it would be a pretty awkward place to film, but just some warm soapy water really cleaned a lot of this up. There's still some scratches and gouges and stuff, but it's looking much better. I also was sort of fiddling around last night, and you might have noticed that there was some corrosion on a lot of these corners and probably some of the sides, the edges. So I used some white vinegar on a Q-tip and scrubbed those down, and that worked really well. So I didn't film any of that, but this top part has all sorts of different types of corrosion and rust, and yeah, this thing definitely spent some time. It looks almost like face down in the water or something. It's kind of an interesting wear pattern here. But just real quick, I'm going to show you how I was scrubbing some of that corrosion with the vinegar. And then after that, we'll get this sort of put back together enough that we can go into some of the configuration options. So I got everything put back together. You may have noticed when I was installing the fan, I didn't use these anti-vibration mounts that came with the fan itself, just because the way that the screw holes were over there for the bottom two screws, basically I would not be able to pull those through. There wasn't enough clearance at all. So instead what I did was use these NA-SAV4s. These are great, they come in a pack. And I'm not entirely sure what the difference is between the SAV 2s, 3s, and 4s, except that the 4s have the flush end here. It's really beveled, but they call it flush. But the other ones I saw, it's almost like they have a little point that sticks out here. So imagine if you like jammed these two together. So this would be sticking out the back, and I didn't want that. I wanted something sort of flush, so I went with these. I just wanted to get a spin around to the back here so you could see what I meant by how it's mounted here. So we're able to keep that original metal grill, and then here's our little beveled connectors. So they do stick out a little bit, but I think it looks pretty good. Very satisfied with how this turned out. So that's going to be it for this video. It ended up being a little bit longer than I had anticipated. So next time we're going to get into the software config on this. We're going to see if we can actually take a look at what's already on here from whoever was using it previously, and then set it up for ourselves. So we'll also be interfacing this with some sort of AdTran device. I have one or two around here that we could use, and that'll supply our T1. So stay tuned for that video, but until then, got a nice refurbished PortMaster 3.